adding, subtracting, multiplying, and simplifying division. First off, to find the sum of a complex number, you simply find the sum of the real components and you find the sum of the imaginary components. Basically, you treat I as if it were a variable. Even though it's not, the value of it is the square root of -1, you simply treat it as if it's a variable in terms of how you go about adding and subtracting. So here's our adding rule. M plus Ni plus P plus Qi. I add the M. Let's see if I can. I add the M and the P together. And then I add the N and the Q together. And I put the I out here next to it. Let's take a look at a couple of examples. Okay. If I want to add 7 plus 5i plus 8 minus 3i, I'm going to add the 7 and the 8 to get 15. And I'm going to add the 5 and the -3 to get 2. So here we go. Try these next two. Pretty basic, pretty simple. Or at least try number 2. Pause the video if you need to. And here it is. 2 plus -8 is -6. 3 plus -6 is -3. If I express the sum, 3 plus the square root of -64 and 10 plus the square root of -25, you have to remember that this is 3 plus 8i plus 10 plus 5i. Simplify the radicals first. Put it in A, the real portion, plus BI, the imaginary portion. And then add the reals, add the imaginaries. You get 13 plus 3i. Oops, it should have been a minus there. Sorry about that. That's a minus. Let's look at a few more. Try this one. Pause the video. Now let's take a look. Do I need that 1 in front of the I? No, I don't. I could just leave it -2 plus I root 2. It's like anything. You don't have to have the 1. If you put it there, I'm not going to mark it wrong. Subtracting. It's the same thing. You simply subtract the real components, subtract the imaginary components. Ready, set, go. Let's try these. Go ahead and try these. There's 3 of them there. Pause the video. Now check. Did you do the work correctly? Did you do the work correctly? Now here, read the words. Subtract this from that. So it's 9 plus square root of -36 minus. Okay? Subtract this from that. Make sure you read the problem and put it in the correct order. If you messed up on this one, try this one. And did you get it? Good job. Again, you've got to make sure that you're reading the problem correctly. So adding and subtracting, pretty simple. Multiplying complex numbers, really not any different. You're foiling. Now here, the big thing with the foiling is you've got to realize that the I squared is going to be equal to -1. In the end, you're still going to just have an A plus BI form. It's distributive multiplication or FOIL. You're still going to do first, outer, inner, last. So here's your example. 2 plus 3i times 4 plus 5i. I multiply the 2 times the 4 plus the 5i, and then the 3 times the 4 plus the 5i. I then take this I squared. I squared is the same thing as -1. -1 times the 15 is -15. Notice I simplify the answer down so that I have a real portion and an imaginary portion. Make sure you simplify the I squared to -1 and further simplify your answer. When you divide, Oops, let me make sure that I didn't skip anything back here. Nope. Okay. When you divide, you've got it, or when you're dividing two, you're going to work with the conjugate. The conjugate is merely taking the opposite of the imaginary portion, not the real portion. If you have a plus bi, its conjugate is a minus bi. I don't change the a, just the imaginary portion. So 4 plus 2i, I get 4 minus 2i. Now recall, multiplying the difference, or multiplying a plus b times a minus b, that gives me the difference of squares. It eliminates a middle term. So if I multiply a complex number and its conjugate, I'm going to get a real number. If I multiply a complex number and its conjugate, a plus bi times a minus bi, notice the abi is plus and it's minus, and it becomes a zero pair. And I have a squared minus b squared I squared. I squared is 1, so I wind up with a squared plus b squared. This is a real number, so there are no i's. I'm going to use the conjugate to clear any denominators. Remember, we care about conjugates because we're going to use them to get rid of imaginary units that show up in our denominator of a fraction. We do this just like we use conjugates for radicals. Imaginary units are forbidden in the denominator. They're forbidden in the denominator because an imaginary unit represents a radical. Let's look at some problems. When dividing two complex numbers, you simply have to clear the denominator. I've got 3 minus I. Well, I multiply it by a form of 1. So 3 plus I over 3 plus I. 3 plus I is the conjugate. The top I have to FOIL. The bottom, it winds up being the difference of squares. 9 minus negative 1. Well, that's just 10. And I simplify. Again, the conjugate, use the conjugate so that you have a difference of squares that eliminates the middle term, so it eliminates the I. The conjugate of a plus bi is a minus bi. Conjugates are used to divide complex numbers just as they are used to divide radicals. If I divide 5 plus I by 4 minus 2i, I have to multiply by a form of 1. The multiplicative identity, and I use the conjugate of 4 minus 2i. Notice it's 4 plus 2i. I only change the imaginary part. The top I have to FOIL. The bottom I can either recognize that it's a difference of squares, or I can FOIL it and simplify. Here I've shown you all the work. You need to study that. It's simply 5 times 4 is the 20. 5 times the 2i is 10i. I times 4 is 4i. I times 2i is 2i squared. 10 and 4 is 14. 2i squared. I squared is negative 1. 2 times negative 1 is negative 2 plus the 20. That's where I got the 18. I still have 14i. It's all over 20. Again, 16, 8i minus 8i minus 4i squared. I squared is negative 1. That's how you got the plus. Everything's even. I simplify it. Try this next one. Pause the video. I've already set up so that I've shown you exactly what the conjugate is. You'll have to be able to come up with the conjugate by yourself. And try this one. Pause the video. Check your work against this work. And tell me, how did you do? Okay, I'm going to stop it here and we'll come back and represent complex numbers graphically.